నమస్కారం అండి. నా పేరు డాక్టర్ 𝗳𝗧 𝗚𝗃. నాతో పాటు ఇవాళ మిస్టర్ ఎస్ కృష్ణ ప్రసాద్ ఉన్నారు. గురుకుల ఉద్యోగ గైడ్లో ఫిజిక్స్ సిలబస్ గురించి అవేర్నెస్కి ఇవాళ మేము లెక్చర్స్ ఇస్తాము. నేను భవన్స్ కాలేజ్ ప్రిన్సిపల్, భవన్స్ వివేకానంద కాలేజ్ సైనిక్పురి సికింద్రాబాద్. నాతో పాటు ఇవాళ మన ఎస్ కృష్ణ ప్రసాద్ కూడా ఉన్నారు. ఇంట్రడ్యూస్.
Myself S. Krishna Prasad, Assistant Professor of Physics from SRR Government Arts and Science College, Karimnagar.
సో ఇవాళ నెక్స్ట్ పేపర్ 2 సిలబస్లో మనకి మెయిన్గా టాపిక్స్ మ్యాథమెటికల్ మెథడ్స్ ఆఫ్ ఫిజిక్స్, క్లాసికల్ మెకానిక్స్, ఎలక్ట్రోమాగ్నెటిక్ థియరీ, క్వాంటమ్ మెకానిక్స్, థర్మోడైనమిక్స్ అండ్ స్టాటిస్టికల్ ఫిజిక్స్, ఎలక్ట్రానిక్స్, అటామిక్ అండ్ మాలిక్యులర్ ఫిజిక్స్, న్యూక్లియర్ పార్టికల్ ఫిజిక్స్ అండ్ కండెన్స్డ్ మ్యాటర్ ఫిజిక్స్. ఇవి మనకి మెయిన్ చాప్టర్స్. ఇవి కాకుండా సేమ్ టాపిక్స్తో కొన్ని అడ్వాన్స్ టాపిక్స్ కూడా మళ్ళీ రిపీట్ అవుతుంటాయి. మీ సిలబస్లో చూస్తే హెడ్డింగ్స్ ఇవే ఉంటాయి, కాకపోతే అవి కొంచెం అడ్వాన్స్ టాపిక్స్ ఉంటాయి. సో ఇకపోతే ఈ చాప్టర్స్లో ఏమేం సిలబస్ కవర్ అవుతుంది, ఏమేం టాపిక్స్ ఉంటాయి అండ్ హౌ టు గో అబౌట్ ఫ్రమ్ ఈచ్ చాప్టర్, అది వీ విల్ ట్రై టు ఎక్స్ప్లెయిన్ ఫర్ ఆల్ ఆఫ్ యూ టుడే. We will start with first chapter, that is mathematical methods of physics. దీంట్లో మెయిన్గా we will see the vector analysis, vector algebra, linear algebra, matrices, 𝗘𝗽-Hamilton theorem, eigenvalues, the three mathematical functions, that is Bessel's, Lagrange and Legend functions, Fourier series, Laplace transforms. All these topics are mainly associated in different branches of physics. So particularly when you come to 𝗘𝗽-Hamilton theorem, provides a tool for understanding the behavior of square matrices and their widespread applications in mathematics and physics and engineering. So the four polynomials we generally come across in mathematical physics are Hermite polynomials, Bessel's functions, Lagrange functions and Legend functions. These are all orthogonal polynomials and they are particularly useful in the study of quantum mechanics, quantum harmonic oscillators and their applications in probability theory and signal processing. Hermite polynomials are mainly used in quantum mechanics, probability theory and signal processing, whereas Bessel's functions, they describe oscillatory phenomena and are particularly useful in problems involving cylindrical symmetry. Wherever there is this particular function will be very easy to solve. Bessel's functions have applications including acoustic, electromagnetics, fluid dynamics and quantum mechanics. Coming to Lagrange functions, these are they find mainly applications in the areas of optics, atomic physics and solutions of differential equations. They are also very much used in quantum mechanics, and wherever the radial part of the solution of the Schrodinger wave equation is involved, these functions will become very easy to solve. Alage, if we come to Legend's functions, these involve problems in spherical symmetry such as potential theory, electromechanics and quantum mechanics. Legendre polynomials have important applications including the expansion of functions in terms of spherical harmonics, gravitational potential theory and study of magnetic field. So if we come across some questions like this, Hermite functions are commonly used in the study of. So as we have seen in the previous case, the four options are circular symmetry, spherical symmetry, quantum harmonic oscillators and diffusion process. So generally Hermite functions will be very much useful in quantum harmonic oscillators. Similarly, when we come to Lagrange functions, they are mainly useful in fluid dynamics and statistical mechanics. Alage Legend's functions koste, they are mainly useful whenever there is a spherical symmetry involved, so the option will be B. Krishna Prasad garu.
Yeah, in vector calculus usually these questions are asking frequently, and about the position vector, as you know very well, that is 𝗓𝗏 plus 𝗓𝗏 plus 𝗓𝗏, its gradient, divergence and curl of its operation, and you will be asked. Whenever you are going to prepare for the vector calculus, I would like to give some gist, that is even though
del dot r,
whenever you are going to read about these things, first of all you must concentrate on the definition as well as its physical significance. For example, if you take the gradient of a scalar function, it will be obviously a vector function, but that vector is perpendicular to the plane which was given. And if you are given a function like this surface, you will be asked a question like this, that is x square y I cap x square y plus z square y square z plus z square x. If this is the scalar function, then you will be asked to find a vector which is perpendicular to the given surface. So you are not you will be not asked to calculate the gradient of that particular surface directly, you will be asked indirectly. If you know about the what is gradient and what is its significance, then simply you can answer that question. That is nothing but the gradient of the given scalar function itself is the vector which is perpendicular to that surface. And also you must know that if you are asked to calculate the a vector, unit vector perpendicular to the given surface, then what you have to do is, as on the slide you are given a problem, to calculate that problem a hint is given, you can see on the slide, that is whenever a scalar function is given and you are asked to calculate its unit vector along that particular direction perpendicular to that surface, then simply what you have to do is you have to calculate the grad r and by grad phi. If you do so, then obviously you will get that answer. And as you know, the position vector of a particular point in the Cartesian coordinate system, it is given by x is r bar is equals to xi cap plus yj cap plus zk cap, and usually there are some I am just giving some gist about the vector calculus, that is del bar dot r bar you will be asked, that is the where del bar is the del operator, the which you know well, that is I dou by dou x plus j dou by dou y plus k dou by dou z, and if it is dot producted with the position vector, then it will be dou x by dou x plus dou x dou y by dou y plus dou z by dou z. So simply you will get the answer, that is 3. And if you do the curl of that vector, that is the del bar cross r bar, that is the cross product of the del operator with the position vector, it will give you 0. So what I mean to say here is, whenever you are going to prepare for a particular topic in the mathematical physics, if it is vector calculus, then what you have to do is, if position vector is given, its del bar dot r bar is 3 and del bar cross r bar is 0. These things you have to keep in mind. If you what I mean to say here is, without doing the question itself you can put the answer, because you are given only 120 minutes of time. During that time you have to answer for 100 questions. So it is very useful if you remember the standard formulas and its physical significances, then it is very fine to solve the problems which are given in the mathematical physics.
The next chapter is we have in the syllabus is classical mechanics. Classical mechanics has topics like Newton's laws, dynamical systems, phase space dynamics, stability analysis, central force motions, two body collisions, scattering in laboratory and center of mass of frame of reference, rigid body dynamics, moment of inertia, inertia tensor, non-inertial frames, and pseudo forces. So variational principle, generalized coordinates, Lagrangian and Hamiltonian formalizations and equations of motion, conservation of laws and cyclic coordinates, periodic motion and small oscillations, normal modes, special theory of relativity, Lorentz transformation, relativistic kinematics, and mass energy equivalence. So these are the general topics which we go through right from the beginning of our education, and particularly all these topics are covered under classical mechanics. So we all know that when it is a two body collision, we try to solve the collisions in two dimensional and 3-dimensional cases, and we try to establish the relationship between initial velocities and final velocities, and also the angles, scattering angle and recoil angle. And this two body problem, two body dimensional collision in 2 dimensions is very important when we come to the case of Rutherford scattering experiment, and we apply these basic principles to solve Rutherford scattering experiment. And we in Rutherford scattering experiment we try to find the relation between impact parameter and the scattering angle, and clearly establish that the scattering angle is inversely proportional to the impact parameter. So, in this way we can apply the two body oscillations scattering in laboratory frame, and also one more important thing is how the collision can be seen from laboratory frame of reference and center of mass of frame of reference. The same collision whatever we see in laboratory frame of reference, when you go to center of mass of frame of reference, we have to understand that our point will be center of mass. With respect to center of mass, the two bodies which were moving in same direction in laboratory frame of reference will move opposite direction in center of mass of frame of reference, because center of mass of origin is fixed at the center of mass of frame of reference. Similarly, after collision also again the two bodies appears to move opposite from each other, whereas the same problem when viewed from laboratory frame of reference, still they may be travelling with same velocities. So, we have to understand the relation between the quantities in laboratory frame of reference and center of mass of frame of reference. So, that will make the solving of two body collision problems very easy. And again when come to, as I said, we have laboratory frame of reference and center of frame of reference. So, frames of reference is very important when you are understanding the collisions. Similarly, those if you are considering some forces are dependent on frames of reference and some vectors are not dependent on frames of reference, pseudo forces are for example for that. Similarly, whenever we want to solve these problems in classical mechanics, Lagrange's and Hamiltonian formalisms becomes very important. We can solve most of the problems using these two formalisms. So, Lagrange's and Hamilton formalisms are mathematical frameworks used in classical mechanics to describe the dynamics of physical systems. They provide alternative ways to analyze and derive the equations of motion governing the behavior of a system. Lagrange's formulation is based on the principle of least action, which states that the actual path taken by system between 2 points in space and time is the one that minimizes the action integral. Similarly, these equations describe the evolution of the system over time and determine the trajectories followed by the general coordinates. Coming to Hamilton formalizations provides an alternate formalization for classical mechanics using the concept of Hamiltonian function. These equations describe the general coordinates and moments of systems evolve over time. By solving these equations, one can determine the trajectories followed by the generalized coordinates and momentum, and consequently we can obtain the equation of motion for the system. Few examples, like as already I have explained you, the Lagrangian formulation in classical mechanism is based on the principle of least action. So, answer will be B. Similarly, when you come to Hamiltonian function, it is defined as the sum of basic understanding. We know that this is wherever we involve, it is sum of kinetic energy and potential energy. Krishna Prasad garu.
Yeah, in classical mechanics you have to concentrate on basics of special theory of relativity, in which that is the length contraction and time dilation and relative velocity problems. And for example, if you look at the problem, a problem is given, the mass of the electron is double of rest mass of the electron. If it is double of its rest mass, then what will be its velocity? For that, you must know the formula that is given by m is equals to m naught by root over 1 minus v square by c square. If you remember this formula, then simply you can do the problem by substituting in this, that is 2 m naught is equals to m naught by root over 1 minus v square by c square. Thereby you can calculate, that is root over 1 minus v square by c square will be equals to 1 by 2. Thereby 1 minus v square by c square equals to 1 by 4. Therefore, v square by c square, it will be given by 1 minus 1 by 4 means that is 3 by 4. So, v square is equals to root 3 by 4 c square, and v is equals to root 3 by 2 into c. In this way you can calculate, if you remember the problem, what I mean to say, the formula. So, the formulas for time dilation, length contraction and relative velocity and all these things from the special theory of relativity you have to remember, And the next one what I want to say is about the Lagrangian formulation. Lagrangian formulation is used to describe the dynamical system for the conservative systems as well as for the non-conservative system, and you will be asked in the examination directly to write the Lagrangian equation for conservative system and Lagrangian equation for non-conservative system. So, it is a big lengthy proof may be there, but the end product you have to remember, that is no doubt at all. And while preparing for your examination, you have to make some flashcards, something like that, in where you have to write all the end equations what you have got, and what are the physical significance of that equation also you have to remember. And for example, if you look at the equation, that is the Lagrangian equation for a conservative system, that is you will be asked directly, that you must know that is given by d by dt of dou L by dou qk dot minus dou L by dou qk is equals to 0. If it is in the case of non-conservative system, it will be equals to qk, that is the generalized force. And now you will be asked some questions on basic fundamentals of that is the generalized coordinates. If the generalized coordinate is represented by a momentum, if generalized coordinate is represented by a momentum, actually here time not supports me to explain about all the generalized coordinates, constraints and all those things, but just to give some idea about those things, I prepared some questions like if generalized coordinate is momentum, what momentum's dimension, if it is there, then what will be the dimensions of velocity. Means if generalized coordinate usually it represents the position, but here in this case that position has the dimension of momentum. So, you are asked to calculate the dimensions of velocity. So, for that what you have to do is you have to differentiate that given generalized coordinate. You are given the generalized coordinate is momentum. If you differentiate that, obviously you will get the answer force. So, that is the differentiation of momentum with respect to time, it will be given by force. So, similarly you will be asked one more question, that is if the generalized coordinate is angular momentum, and if it is the product of the angular momentum and associated with the generalized coordinate, and what it will be, you will be asked. Then here also you have to understood that angular momentum, angular momentum, that is momentum multiplied by the position coordinate, that is r, obviously it will give you the answer, that is mvr. So, if momentum is generalized coordinate and the product of it with the coordinate, that is the generalized coordinate, that will give you the angular momentum. And also some coordinates are there like cyclic coordinates. Cyclic coordinates means for a dynamical system, the Lagrangian will be expressed by some coordinates, and if one of the coordinate is absent in the Lagrangian, then that coordinate is said to be a cyclic coordinate. That is if that is what I mean to say, L by L is a Lagrangian, it is the function of generalized coordinates and time, that is q1, q2, q3 dash 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 up to qn and t. If one coordinate is absent, say, then dou L by, if qk coordinate is absent, then that dou L by dou qk will be is equals to 0. And based on this you will be asked some questions, that is if what I meant to say, that is the velocity position vector, you know very well the Lagrangian equation, that is given by d by dt of dou L by dou qk dot minus dou L by dou qk is equals to 0 for the conservative system. If dou L by dou qk is equals to 0, then what you will get, the remaining equation will be d by dt of dou L by dou qk dot, that is equals to 0. If generalized coordinate is cyclic, then simply what you can do for this equation is, if in case of L, you know very well the Lagrangian is nothing but the difference of kinetic energy T and the potential energy V, that is T minus V. So, if qk is cyclic, dou L by dou qk is 0, the remaining will be d by dt of dou L by dou qk dot is equals to 0. So, In case of L, what you will get there only is just nothing but the kinetic energy, because that ∂L/∂Q generalized coordinate is cyclic. So, if it is the position coordinate, if it is the cyclic, then in place of L you have only T, I mean kinetic energy, that is the half m_q_k dot square. If you square it, if you differentiate it with respect to qk dot, then you will get only m_q_k dot. So, in Lagrangian, from the Lagrangian equation you will get d by dt of m_q_k dot is equals to 0. So, from this you can say m_q_k dot is equals to a constant one. So, whenever a position coordinate is cyclic, then its momentum is what I mean to say constant, momentum is constant. And similarly, some problems based on the Lagrangian equation you will be asked about linear harmonic oscillator, a simple pendulum, compound pendulum, like this some systems are there, and when bead is sliding over a surface of a sphere, and all these questions are very important, but in the examination to solve these problems it is very difficult and time will not permit you. So, my suggestion is please go through the example problems, and what you have obtained at the end, you have to remember that equations. If it is very useful to pick out the answers from the given choices. For example, if you take the linear harmonic oscillator and you are asked to write the Lagrangian of a linear harmonic oscillator, then that is nothing but L is equals to T minus V. So, the T is the kinetic energy, that is nothing but the 1 by 2 m x dot square, where x is the position coordinate, x dot square will be the V square, and minus half k x square, that is the potential energy of the linear harmonic oscillator. So, if you remember some equations, so to if you remember some equations, then it will be very easy. So, as you got that L value, that is L is equals to half m x dot square minus half k x square, then you can have the Lagrangian equations, that is the equations of motion, from that equation very easily. So, it is better to make flashcards and write the end equations, what I mean to say, the result equations what you have got, and its physical significance also you have to remember. It is very useful in picking of answers from the given choices in the examination.
The next chapter we will have here is electromagnetic theory. In electromagnetic theory we cover both electrostatics, electric field, magnetism, and also the electromagnetic induction principles. So, mainly we know that whenever you deal with electrostatics, Gauss law is very important, and by application of Gauss law for different charge distributions we can find the formulas for electric field intensity. And when coming to magnetostatics, it is mainly we use Biot-Savart's law and Ampere's theorem. Both laws will help us to determine the magnetic field intensity with different kinds of magnetic distributions, magnetism distributions. So, now when we have both electricity and magnetism combined, we get electromagnetic induction, and there we will generally see how to get electric field using magnetic field and how to get a magnetic field using electric field. We know that whenever an electric field is there and if a charged particle moves, and around that there will be a magnetic field. Similarly, if you use an alternating magnetic field, then you can generate electricity. So, this is the interrelationship between them, and in the Maxwell's concept, coupling all the concepts, that is electricity, magnetism and electromagnetic induction, Maxwell has proposed 4 fundamental equations which will help you to solve any problem in electromagnetic theory. So, therefore, the Maxwell's equations are very important, and you need to modify them according to the distribution which is given to you, whether it is a free space, whether it is a linear isotropic media, or whether it is complex charge distribution. If we are aware and we can apply these Maxwell's equations, we can do most of the problems associated with electromagnetic theory. Apart from electrostatics, we do also have dielectrics and conductors, how the electric field behaves when you have a dielectric material, and how when you have a conducting material, what happens when you apply electric field and magnetic field, that also is very important. And also we have to be aware of charged particles moving in both electric and magnetic fields. So, therefore, we can get a very strong concepts of this chapter and you will be able to answer the questions. We do have Maxwell's equations, as I was telling. Maxwell's equations, it is all actually grouping of all the basic fundamental laws which we have in electricity and magnetism. Like for example, Gauss law of electric fields is there, that is del dot E is equal to rho by epsilon naught. Similarly, when you go for Gauss law in magnetisms, it is del dot B is equal to 0. Similarly, we have Faraday's laws of electromagnetic induction, where we use del cross E is equal to minus dou B by dou T. And Ampere's law with Maxwell's addition, that is del cross B is equal to mu naught J plus mu naught epsilon naught dou E by dou T. Here one should be aware that only Ampere's law, if you consider it, is del cross B is equal to mu naught J, but Maxwell, when he was deriving, he found out that there is some component missing, and that component he has given reason that it is because of the something called displacement current. So, he added that part and he has given additional factor there, that is called Maxwell's addition, that is mu naught epsilon naught dou E by dou T. Clearly, it is dou E by dou T indicates that whenever your electric field is varying with respect to time, this component will come. Otherwise, if you have stationary electric fields, simply the equation will reduce to Ampere's law, that is nothing but del cross B is equal to mu naught J. So, Maxwell's equations, when you want to apply small modification, we have here rho as a charge density, J as current density, E is electric field intensity, B is magnetic field intensity. So, if you are going into say a case where you want to apply Maxwell's equations in linear isotropic mediums. So, whenever they are linear isotropic mediums, the simple observation or simple condition we should impart there is rho is equal to 0 and J is equal to 0, because they are linear isotropic, properties are same in all directions. Therefore, rho equal to 0 and J equal to 0 will be the condition. Apart from that, we also make electric field intensity will change to electric displacement field D, and magnetic field intensity instead of B we use H. So, if we can make this small correction, we can rewrite the equations for isotropic linear isotropic medium. Now, another important aspect when you come to this electromagnetic induction or electromagnetic theory is how electric field intensity vector and how the magnetic field intensity vector change when you get an interface between two mediums. So, therefore, one should be very much aware of the boundary conditions that are applicable for the interfaces between two media. We know that the boundary conditions, the four boundary conditions we have is the continuity of tangential electric field. Tangential electric field will be always continue at the boundary at the interface between the two boundaries. But when you come to the normal electric field component, it is not continuous, it is discontinuous. Similar is the case with even magnetic field, continuity of tangential magnetic field, whereas normal magnetic field will be discontinuous. These boundary conditions ensure that these boundary conditions are always based on the simple principle that it is law of conservation of electromagnetic flux and charge at the interface between different media. So, the total flux entering must be equal to the total flux leaving. So, that is law of conservation of electromagnetic flux, and also the charge should be always conserved. And these equations, Maxwell's equations coupled with boundary conditions, provide a foundation for understanding and analyzing the behavior of electromagnetic fields in the space and linear isotropic medium, as well as their interaction at the interface. So, when you see simple equation, what is the equation? Del dot E is equal to rho by epsilon represents, it is nothing but Gauss law in electric field, and in case of linear isotropic medium, Maxwell's equations are modified by introducing, as I said, electric field intensity will become the electric displacement, and the magnetic field intensity will become magnetic field magnetizing force, that is H. And also one should be aware of the magnetic the motion of the charged particles in these electric and magnetic fields. So, how electric force acts on a charged particle and how magnetic force acts on a charged particle. If we are aware and you understand how the electric charge moves in magnetic field and electric field, then you can apply the concepts and understand the phenomena like magnetic focusing, magnetic filtration, and also the working basic principles of working of electron microscopes, where where all the electric fields and magnetic fields act like convex and concave lenses and try to focus the beam of electrons. So, therefore, it is very essential that you be aware of all the motion of a charged particle in different kinds of electric fields and magnetic fields. So, the force experienced by a charged particle in an homogeneous electric field is given by the equation. If it is a homogeneous electric field, the force is simple, that is F is equal to QE. When it comes to magnetic field, then we know that the force is F is equal to Q into V cross B. So, but because this is electric field, so option will be A. In a inhomogeneous magnetic field, the charged particles experiences a force known as inhomogeneous magnetic field, it will be a magnetic force, right. So, there will be many situations where both electric field and magnetic field simultaneously act on a particle. The next chapter we deal with is quantum mechanics.
So, before going to that, in electromagnetic theory, that Gauss law and some of the applications are there, Ampere's law, the basic fundamentals are very important. While you are going to write the examination, you will be asked if a moving particle, moving charged particle, what it produces? It produces electric field, it produces magnetic field, does it produces both or only produces electric field? Like these questions you will be posed. So, to solve like these theoretical questions also, it is very important to understand the concept very well, and the thing that is the Lorentz force that is given by F is equals to QE plus Q into V bar cross B bar, it is there. And here whenever a neutron particle is entered into a magnetic field or electric field, what is the force acted on that? Like this tricky questions also may be asked. So, neutron has no charge, so no force is acting on that particle, that you have to understood. And Gauss law applications are, so many applications are there, linear wire is there, sheet is there, and spherical distribution charge is there. For all these things you will get some equations for electric field intensity as well as electric potential, and for that based on that what you have to do is you have to remember the end answer for the electric field as well as for electric potential. From that you will be asked the electric field intensity because of spherical charge distribution at a particular point will be proportional to something like that question you will be asked. If you know the equation and if you understand the expression what you have got for that for electric field intensity, then you can pick the answer very easily. So, what I want to conclude here in electromagnetic theory is, first of all you have to read very well about the basic concepts, and you must understood very well, and at the same time you must be able to apply the learned concepts and formulas to the given situations, and some standard situations are there. For that standard situations, the results what you have got, that should be written on a flashcard, and you have to remember. If you remember, so it will become very easy to pick the answers from the given choices in your examination.
As Krishna Prasad sir told correctly, like for example, the fundamental thing is, if you have electric force, in which direction electric force acts? Electric force always acts in the direction of electric field. Similarly, in which direction the magnetic force acts? Not unlike electric field, magnetic force acts in a direction perpendicular to the direction of motion and direction of magnetic field. So, if a charged particle is moving in the direction of magnetic field, then it will not experience any force. These small aspects, if you can remember, it will be easy to answer the multiple choice questions in any entrance. So, coming to quantum mechanics, as we are all aware, this is a very important concept and little bit complicated also. You should have a good understanding about the particles. When it is quantum mechanics, one should always immediately it will strike us is nothing but Schrodinger and equations. Schrodinger wave equation, which actually is like general wave equation for particle waves. We know that for any electromagnetic wave, we have a wave equation of dou square y by dou x square is equal to v square into dou square y by dou t square, right. This is a very simple equation for any wave, any electromagnetic wave, but when it comes to a particle wave, so Schrodinger has provided a very simple two sets of equations which are famously known as time dependent and time independent equations, and we can apply these Schrodinger wave equations to different kinds of examples, that is particle in a box, harmonic oscillator, and we can derive the various energy levels associated with these waves. So, when we another thing which we come across in an quantum mechanics is about eigenvalues and eigen constants. These are also play important role in understanding the quantum mechanics. Apart from that, we have Heisenberg's uncertainty principle and motion in central potential, orbital angular momentum, algebra, spin, addition of angular momentum, time dependent perturbation theory and applications, variational method, time dependent perturbation theory, and Fermi's golden rule. Like these selection rules are there. Whenever we want to understand the chapter, we should be aware of all these fundamental things. Just a small information about, I have not gone into the depth of quantum mechanics because you should do, these are all lengthy equations and you should be thorough of all these equations. I just presented few examples of eigenvalue problems or mathematical problems that involve finding the eigenvalues and corresponding eigenvectors for a given matrix or operator. In general quantum mechanics, all the physical quantities now becomes operators, and we should know that what are the eigenvalues and eigenfunctions for these respective operators. These problems having wide ranging applications in various fields, including physics, engineering, computer science, and also data analysis, right. So, having knowledge about eigenvalues and eigenvectors, it becomes very easy for you to apply the principles of quantum mechanics. So, simple question I have presented there in the slide is in context of matrices, the eigenvalues and eigenvectors satisfy what equation. We are very any time when we start eigenvalue, this is the equation we said, you operator on a function, it will give you some constant into function back. So, A is an operator, V is a function, then lambda V. So, A V is equal to lambda V. Generally this we write it as A psi is equal to lambda psi in our notations. Here it is which we have written as V. Similarly, eigenvalue problems are used in the analysis of vibrational modes and natural frequencies, principal components in data analysis, quantum mechanics. They are useful in all the three cases. So, opt answer will be all the above. So, there are some important points to note in quantum mechanics which are,
yeah. In quantum mechanics, it is the very interesting and very important for your examination, and in this the dual nature of matter from the de Broglie's hypothesis it starts, as well as the radiation, that is the light is having dual nature. Similarly, the matter particle also has dual nature, and its associated wavelength is given by lambda equals to h by p. This is the hypothesis given by de Broglie hypothesis. Starting from that end to the perturbation theory, you must thoroughly, you have to read all the chapters and subtopics which were given in the syllabus. That is very important. And while preparing the examination, for examination point of view, what you have to do is, for example, if de Broglie hypothesis is there, that is lambda equals to h by p, and that p can be written as square root over 2me, where E is the kinetic energy, right. So, lambda has got now another equation, that is h by root over 2me, and if the system is in thermal equilibrium, then that equation will become, that is lambda equals to h by root over 2m kt, where k is the Boltzmann constant and T is the absolute temperature. So, here what I mean to say is, if there is an equation for a particular system, in different situations that equation takes different forms. So, whenever you are going to solve the problems in the quantum mechanics, you must know all these various forms of that particular equation. So, it is better to write all the equations again and again on your flashcards, and if you do remember all these things, it is very useful. And coming to the postulates of quantum mechanics, that is also the very important thing. From the fundamentals also you are giving some questions. Each and every system will be represented with a wave function, that is the most important concept. And about the probability of finding the particle, and that is also given by integration from 𝜓 star 𝜓 d tau. If it is normalized, if it is the function is not normalized, then integration 𝜓 star 𝜓 d tau by 𝜓 star d tau. Something like this equations are there. For normalized condition, 𝜓 star 𝜓 d tau is equals to 1. If it is so, then that wave function is said to be normalized. And here finding the probability, finding the particle and operators, these are all very important concept. As you know, each and every observable measurable quantity in the quantum mechanics is associated with the operators. If you know very well about the operators, then only you can solve the problems which were given as application, otherwise you can't. For example, displacement coordinate systems, if you take, that is x, y, z in classical mechanics, they are represented by x hat, y hat and z hat as usual in quantum mechanics operators. In coming to the momentum operator, that is p is given by minus 𝗂 cut del is there. So that components can be written as px is equals to minus 𝗂 cut dou by dou x, py is equals to minus 𝗂 cut dou by dou y, and pz is equals to minus 𝗂 cut dou by dou z. Like this you must remember. And similarly, angular momentum operator is also there, that is given by L bar. As you know, L bar is nothing but the r bar cross p bar, and that is the cross product of the position vector and the momentum operator. Here we have to take operators. If you do so, then what you will get is you will get the angular momentum operator. And coming to the notations, the Dirac notation is very simple and very interesting, and it is very useful in solving the problems also. That is a state function, each and every state function is represented with a ket vector. That ket vector is shown on the slide, that you can see that ket vector, each and every state function, state of a particle is represented with a ket vector, and it is associated in that particular Hilbert space, right, and its complex conjugate is represented with a bra vector. And you know, the scalar product of two vectors can be represented bra ket. That is, as you can see on the slide, if phi and psi are two vectors, then its scalar product, it is also known as the inner product, that is represented by psi bra psi ket phi. And here it is the very important in this quantum mechanics, what you have to concentrate is the order is very important. In some cases only the order may be equal, in some cases it does not equal. That is, if you take two vectors, that is phi and psi, the scalar product or inner product may not be equal to one to another. That is, psi phi bracket is does not equals to phi psi bracket. That is the scalar product of psi and phi, it is does not equals to scalar product of phi and psi, but it is equals to complex conjugate of that, that can be written as minus phi psi, you can write, and it is the very important. And coming to the Hermitian operator, what is Hermitian operator, and all these things you have to learn very well. And coming to the ladder operators, that is a creation and annihilation operator in solving particularly linear harmonic oscillator.
Time is already. So, due to proximity of time, we are not able to completely give all the information, and we are almost coming to the end of the session, almost time. The other chapters which we are quickly overlap is thermodynamics and statistical physics, which deal with the ensembles part, thermodynamic quantities, Maxwell's relations, thermodynamic potentials, principles, black body radiations and Planck's distribution law. These are the few thermodynamic potential which we generally come across in all the degree syllabus. We will move on to the next chapter, that is these are the some electronics topics which we have. The mainly here one should be aware of the optoelectronic devices. We know that fundamentally all semiconductor devices, PN junction, Zener diode, all those things are very important, but apart from that we should move little bit more and learn about optoelectronics devices, rectifiers, power supplies, operational amplifiers, feedback amplifiers, phase shift oscillators, and also A to D and D to A converters. So, this is you should go beyond the normal diodes and transistors, and a few applications in electronics also we should be thorough. Apart from that, in this chapter we also get fiber optic communication as one of the topics. So, these are the few informations which we provide, but we cannot go into details as we have shortage of time. The next chapter we have is atomic and molecular physics. Here we have quantum states of an electron in an atom, electron spin, spectrum of helium and alkali atoms, relativistic corrections for energy levels of hydrogen atom, hyperfine structure, and also Zeeman, Paschen and Stark effects. So, we have electron, and here electron rotational, vibrational and Raman spectra are also important topics, and everyone knows how important Raman spectra is to understand the different kinds of structures and different kinds of elements. Then we have nuclear and particle physics, which is the last chapter, basics of radioactivity, basic nuclear properties, size, shape and charge distribution, spin and parity, binding energy, semi empirical mass formula, liquid drop model, shell model, and independence of charge. So, these are the few topics. So, we want all of you to go through these topics well aware, so that you can write your exams. Thank you all.
All the best for your exams. Thank you.